What is up, YouTube? This is your favorite YouTuber, Coach Carr here, bringing you another video for the midterm review. So this one goes over page 15 through 17, and I hope you enjoy. Okay, so now we are on page 15. I'm going to do number 41 and two of the ones for 42. But for 41, it says, what are the three ways to prove triangles are similar? The ways that we do that, there's only is a postulate, which is finding two angles are congruent. You have side theorem, and last side theorem. So side is all sides are proportionate. Side is when you have two sides proportionate and one angle that's congruent. So down here, I'm going to do this one and this one for number 42. What we're trying to do is say, are the two triangles similar? Explain why or why not. So the first one that I said I was going to do, the other ones I want for practice for you is, you have the symbol here where we're told that this side is congruent to this side. And I'm told that these angles, because of vertical angles, are equal. Now, right now, the only thing we've been told is the angles, and we've actually been told that these sides are congruent. Remember, we're trying to figure out if things are similar. So if the sides are congruent, chances are we're not dealing with one of our similarity statements. So in here, this is going to be not similar. I don't actually have enough information. So I don't really have enough information. I don't have a second angle inside the triangle, and I don't have the ability to check if the sides are proportionate because they didn't give me any side lengths. So I do not have enough info for that one. Now, the other one I said I'm going to do, notice that they both have a right angle. So they both have at least one angle congruent to each other, and then they gave me side lengths for two of the sides. So potentially, we might be talking about side angle side. But in order to know for sure, we have to make sure the sides are proportionate. So what I'm going to do is, I know the 10 goes with the 5. So, and the way I know this is the 10 is the smaller side on this triangle here, and 5 is the smaller side on this triangle. So I know they were the ones that go together. So I have 10 over 5. That equals 2. So in order to be proportionate, that means the other side, when I do this and set up the proportion, also would have to equal 2. So I'm going to, since I started with the bigger triangle last time, I'll do the same thing here. So now I'm dealing with 28, and that goes with the 14, which 28 divided by 14 also equals 2. So these are proportionate. And now that I know that the sides are proportionate and I have one angle that's congruent, I would have side angle side theorem. So I have the side angle side theorem. If I'm writing a similarity statement, I have to say which letters go with which. So I'm going to say triangle TUV is similar to triangle UWX. Okay, so the last problem on this page is number 43, and it's saying campsites F and G are on opposite sides of a lake. A survey crew made the measurements shown on the diagram. What is the distance between the two campsites? The diagram is not to scale. So first thing I want to do is make sure that they are similar. So one thing I do know, I have vertical angles. They're right across from each other. That's something that I can assume when I see it in a picture. So these angles are congruent to each other. Now what I'm going to just do is make sure that the two of the sides are proportional. So the sides that I already have. So 82 goes with the 73.8. I know that because this is the smaller side here, so it's going to go with the smaller side in the other triangle. And that's going to equal 1.11 repeating. So now I just need to make sure that the other side has that. 92 divided by 82.8. That 2 is equal to 1.11 repeating. So I do know that these are similar because of side angle side. Now that I know that they're similar, I'm going to go ahead and set up a proportion in order to figure out this length here, because this is what we're trying to find. So this is, I'm going to give it the variable x. Now, what we want to do is, again, set up a proportion. So I know the 47 goes with this, because that's what I'm trying to find this here. So 47 would correlate with this side. So I'm going to write a proportion that has 47 over, and I don't know what this side is, so I'm going to have it as x. And now I'm going to set that equal to one of the proportions on this side. Now, since I started with this triangle over here, I'm going to pick one of the sides over here. I'm going to choose 92. So I chose the 92, and earlier I said the 92 goes with the 82.8. So 82.8. Now what you want to do is do your cross product. So these are going to be multiplying with each other. So x times 92 is 92x, and 47 times 82.8 is 3,891.6. Now I'm trying to get x by itself, so I'm going to divide by 92. That's so that it cancels out right there. And I have x equals 42.3. And looking at my answers, I do have that answer, so it would be A. Okay, so now for page 16, this one has similar triangles as well. We're trying to see if they are similar. If yes, we're going to state the reason. And what you want to do is look at the picture, see if there's anything you know right away. Well, something that I have noticed is you have these two triangles, but they're both using angle A. So if they're both using this angle, I know the angle must be the same for both because this would be a reflexive angle. So again, both triangles use angle A. So I know it has to be the same for both. Now, in order to do a similarity statement or say which one why they're similar, I have to know something about the sides as well because I can't find any other angles. I haven't been told lines are parallel, and they didn't tell me that angles were congruent to each other. So I can't use angle postulate. But now I'm going to look at the sides. Something that helps some people is to redraw it if they're in the same triangle. So I'm going to redraw it where I'm going to have my small triangle. You have the 9 and the 6, and then I'm going to have my full length triangle, my bigger triangle. And the full length for the bigger one is 21 plus 9, 30, and 6 plus 14 would be 20. So now what I want to do is make sure that the sides that go with each other are proportionate. So let's say if I did the long side 30, well, this goes with the longer side in this one, which is 9. And that's going to get me 3.33 repeating. Now, if I look at the other one, I have 20, and that goes with the 6. If I did 20 divided by 6, I get 3 0.33 repeating. So these are also proportionate. So the reason why they are in fact similar now is because we have side angle side theorem. Now, the other one I'm going to do with you is part C. I want B and D to be practice for you. So for part C, something or hopefully you noticed and I noticed was these symbols here. That's telling me that the lines are parallel. Something that I like to do is extend those lines so I know those are my parallel lines. Now, when I'm dealing with parallel lines, I usually have the transversal. In this case, this bottom one here would be the transversal. So I can probably find some type of angle relationship for this one. And the angle relationship that I would see, I want to make sure I find an angle relationship that actually touches our parallel lines. So if I went here, I could correlate right here. The reason being is these are corresponding angles. And corresponding angles are congruent. So that's how I knew that those ones were equal to each other. Now, I can't figure out any other angles. So what I'm going to want to do is look at the sides I've been given. I have to make sure that they are proportionate. So I'm going to do, if I did this side 15, it would correlate with the 6. So 15 divided by 6 is 2.5. So I have to make sure that the other side I've been given also has that same proportion. So what I'm going to do, 20 divided by 8, because the 20 goes with the 8, that would get me 2.5 as well. So these were proportional and we had an angle that we found. So what we can say is side angle side theorem. Okay, so the last one for page 16 is number 45. It says the triangles shown are similar. So I'm told they're similar. They want me to complete the following. So I have to write the similarity statement and the actual reason why they are similar. So first thing I'm going to do is see if there's anything I notice about the picture. Well, I notice this triangle is directly across from this triangle. So because of vertical angles, I would know that those angles are congruent. So that's something that I know. So I found an angle. Now, none of the sides are being said to be parallel or anything, so that's probably the only angle I'm going to find. So, but I was given side length, so what I'm going to do is make sure they're proportionate. So 15 divided by 5 equals 3. So that means the other side would also have to be proportionate. So 18 divided by 6 also equaled 3. So these are proportionate. Now I knew the 15 went with the 5 because 15 was the smaller side here, so I know it has to go with the smaller side over there. So now you found your sides are proportionate and you found one angle. So the reason why these are similar is because of side angle side. Now the similarity statement, I have to figure out which letters go with which, and the order does in fact matter. So I have to figure out what A goes with. So A was on the side that had 15. I said 15 went with the side that had the 5. So that means my first letter will end up being the D. The next letter they chose was B. B was on the side that had 18. 18 correlated with the 6, so then I know the next letter has to be E. And they both had an angle C. So there we go. Triangle ABC is similar to triangle DEC. So now we're on to page 17. They want us to write the algebraic descriptors for each transformation. As you have noticed, for almost all these, I already wrote the x comma y in parentheses, and then I'm drew the arrow. Algebraic descriptors always start with this, so if you want to pause the video for a second, write this part down, feel free, but in order to save time, that's why I did that. So for a translation is something that slides, it moves. So the new one, you're saying how far the x and how far the y moves. So it can either add or subtract. So you could see it where it does adding or subtracting. And if it did not change, then you don't have to say +0 or -0. You can just leave it as the y or the x, depending on which one you're talking about. Okay, so now all the reflections. So when it says a reflection over y equals x, that means we're reflecting it over a positive slope. So you're creating a positive line. Now, what ends up happening is you just flip whatever your numbers used to be. So it would be y comma x. So whatever the numbers were, you would just flip them. The next one, if it's y equals negative x, that's telling me that I'm dealing with a line that has a negative slope. So what happens here is you still flip them, but you do the opposite sign for the x and the y. So if they were positive, they turn negative. If they were negative, they turn positive. Reflection across the x-axis. When it reflects over the x-axis, the x is what doesn't change, but the y is going to change signs. So if it was positive, it turns negative. If it was negative, it turns positive. Reflection across the y-axis. That's the one where the x changes, but the y stays the same. Now, reflection across y equals a certain number, or when it says x equals a certain number, the thing that's easiest to do is just count how far away it is from that number and then just do that to the opposite side. So count how far is what I'll say with that, because the easiest thing is if you graph it, you see that it's with that new line, it was 3 away. I would continue 3 over on the other side, and that's how I'd find those new points. Dilation of enlargement. Enlargement is saying that it's going to get bigger. So that means dilations is when a shape gets bigger or smaller through multiplication or division. So let's say if I had a scale factor of 2, then it would be getting 2 times bigger. So I would have 2x times 2y. So it would be multiplying. When it's a reduction, you're getting smaller. So let's say, for instance, that I had a scale factor of 1/2. That means I would be dividing the x and the y by 2. Now, dilation of congruence. So congruence means the same. So if you multiplied any number by 1, it would still be the same. So dilation of congruence is just multiplying them by 1. Then the last thing in this chart is the rotations. If I wanted to go 90 degrees clockwise or 270 degrees counterclockwise, I would flip them, and whatever used to be the x value would change signs. Now, rotating 180, this is where you just take whatever point you had and change the signs. So if they were positive, they turn negative. If they were negative, they turn positive. And then rotation 90 degrees counterclockwise or 270 degrees clockwise, we flip them, but whatever used to be the y value would now change signs. So something also to keep in mind is if they don't tell you which way, we assume counterclockwise. because that's the way quadrants go. Because when you have a quadrant, you got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we assume counterclockwise if they don't say. Okay, so the last two problems on this page and for this video is number 47 and 48. 47, what does it mean for a transformation to be rigid? Well, in order to be rigid, the shape would have to move to a different location, but the size and shape stay the same. So now number 48 wants us to list all the transformations and circle the non-rigid motion. So our different transformations are actually the ones that we just did, we talked about above. So you have translation. That's where it slides somewhere. You got reflection. So it's like a mirror. You're flipping it over something. You have rotation. And it's just like it sounds. You rotate it. And then you have dilation. Now, a dilation is one where it can get bigger or smaller. Now, earlier I said to be rigid, they move, but the size and the shape stay the same. Now, the shape stayed the same in a dilation, but the size changes. So the only non-rigid motion would be the dilation. Thanks again for watching. More videos to come. Make sure to like, subscribe, ring that bell, and of course, buy the merch.